Okay, I want to answer the questions in the discussion for today. So let's look at the first one. What does the MS tell you about the molecule? So let's scroll down to the mass spec. And these two, where is it? Right here. The fact that this right here, my M and my M plus 2 peaks, the 1-to-1 ratio tells me it has a bromine. 1-to-1 is bromine. How many different types of carbon does this molecule have? So now we'll look at the C13 NMR. It tells me there are 4 peaks in this region, and then 1, 2, 3 more. So that's a total of 7. How many are not part of the aromatic ring? This is the aromatic region. This is the non-aromatic region. So it's 1, 2, 3. How many neighbors H's does the hextet have at 1.5? As soon as I see hextet, 6 peaks equals 5 neighbors. Okay, and by the same respect, 3 peaks equals 2 neighbors. What type of group is responsible for the signal at 0.9? Anything below 1 must be a CH3. Draw a fragment that accounts for questions 4 through 6. So first we have a hextet, something with 5 neighbors. So these hydrogens right here have 5 neighbors, 2 plus 3. You may wonder why I chose to make this a CH2. Well, I made this a CH2 because I also have something that has 2 neighbors. And this is the thing right here that has 2 neighbors. What does the IR tell me about my molecule? It tells me I have a C-double-bond-C in there somewhere. If we look at it, this right here is my C-double-bond-C. This right here, above 3000, is a C-double-bond-CH. So now we need to draw the structure of this compound. And I want to point out to you, even though we haven't said it so far, this molecule has an aromatic ring. That's what these peaks between 7 and 8 mean. So let's look at the pieces we have. We said we have a Br. We said we have a CH2, CH2, CH3 in one of the previous problems. And we said we have a benzene ring. The only way to put these 3 fragments together and to give us 2 doublets for our aromatic hydrogens is to have the Br and the propyl group para to one another, like this. Let's look at question 2 now. The first question, or problem 2, the first question in problem 2 is, what does the IR tell us about functional groups? We clearly have an OH right here. We have a C-double-bond-C in this region. And I'll draw the C-double-bond-C. And we also have an H on a C-double-bond-C. Now these peaks right here mean we might have a benzene ring in our molecule. So we'll look at that on the NMR. That will tell us for sure. For how many types of carbon, we're going to look at the C13. Counting, we have 1, 2, 3, 4, 5, 6, 7. What produces the signal at 70 ppm in the C13? This is something you want to remember, very important. C single bond O is almost the only thing that will ever show up there. Not C double bond O, C single bond O, which kind of matches the fact that we have an alcohol in this molecule. Excluding the carbons that are part of the aromatic ring, how many other carbons does this molecule have? If we look at the C13, it would be 3. From the integration, how many substituents are there on the benzene ring? So here's my integration. I'm going to divide everything by the smallest number. When I divide everything by 0.3, I get a ratio of 5 hydrogens to, this should say 2 hydrogens, my math was off there, to 1 hydrogen, to 1 hydrogen, to 3 hydrogens. So since my benzene ring has 5 hydrogens on it, there's one not benzene, one non-hydrogen on there. So it has 1 substituent if it has 5 hydrogens. It looks like this: 1, 2, 3, 4, 5 hydrogens, and then an R group on it. Using chemical shift, integration, and splitting, draw a fragment consistent with a double at 3.7. Well, let's look. Since it's about between 3 and 4, it must be the carbon attached to the oxygen. Or I should say the hydrogens on the carbons next to the oxygen. Since the integration is 2, that's why I drew 2 hydrogens there. Since it's a doublet, it has 1 neighbor. So it looks like this. The next question asks us to draw a fragment for the hextet at 2.9. Since it's a hextet, it has 5 neighbors. And since it integrates to 1, I put 1 hydrogen here. What is the molecular weight of the molecule? Well, let's look at the mass spec. According to the mass spec, it's 136. What is the structure of this unknown? Well, let's look at the proton NMR, because that's where we wrote all our fragment. I've got this fragment right here, a CH2 here and a CH here. there must be something coming off of the CH2. There must be something coming off of this H right here. One of those things is going to be a benzene ring, and one of those things is going to be my alcohol. I already know that my alcohol is on a carbon that has 2 hydrogens, so the alcohol must be right here, which means the only place my benzene ring can be is right here. And that is the structure of my molecule. This is the symbol for a benzene ring. Let's look at the third problem now. What do the 2 peaks between 110 and 145 tell us in the C13? These 2 peaks tell us that we have a C double bond C. That's what they tell us, C double bond C. Likewise, these peaks right here tell us we have a C double bond C with H's on them. We're not going to talk about how many they are right now, but we know that we have that H there. How many H's are responsible for the signal at 0.9, and what is the type of group it's from? Well, we know it must be a methyl group because that's the only thing that shows up at about 0.9. But how many there are, we'll have to look at the integration. This integration is a little bit tricky to look at, to figure out. I'm going to divide each one by the smallest number. When we do this, we get 1 to 1 to 1.5 to 1 to 1.5. Now, I know it can't be 1.5, so I'm not going to round. I'm going to multiply everything by 2. When we do this, we get 2 to 2 to 3 to 2 to 3. So the answer to the question is there are 3 hydrogens there giving us the signal. So based on the chemical shift, integration, and splitting, draw a fragment that explains it. So let's look at that. It's a 3 hydrogen triplet, so it must be a CH2CH3. 3 peaks, 2 neighbors. So now we have to do the same thing for the signal at 1.5 ppm. It's a 2 hydrogen hextet, so it has 5 neighbors. So I have 2 hydrogens with 5 neighbors. So based on the integration, what is responsible for the singlet at 1.7? Let's look at the integration. So a singlet, no neighbors, integration of 3, so it's a CH3. CH3 with 0 neighbors. What is responsible for the signal at 4.8 in the NMR? We've kind of already answered that early. We said it's a C double bond C with an H on it, but now we can say there are 2 hydrogens on there, and there are 2 possibilities. They could both be on the same hydrogen, or the same carbon, I should say, or they could be on different carbons. And we're not going to worry about cis or trans right now, but it's one of these 2 possibilities. So what does the IR tell us about this molecule? Well, let's look at the thing that sticks out on the IR is this peak and this peak. C double bond C, C double bond C with the H on it. Draw the structure of the compound. Let's look at our NMR where we have all fragments written. So I either have this kind of double bond or this kind of double bond, and my fragments tell me I have this right here, and my other thing is my CH3 right here. That's a singlet stuck on that double bond. So I need to figure out which is which, or which one it is, I should say. So I've drawn my 2 possibilities, and what I want you to notice is that for this one right here, this CH3 would be a doublet because it has a neighboring hydrogen. It's not a doublet, it's a singlet. This CH3 right here would be a singlet, so this must be the answer. This CH3 would be split into 2 peaks because of that hydrogen. This CH3 would be a singlet, just like we have.